Okay, in this class we're going to learn some new concept, and that is called sequences. Sequences, and also we're going to learn what is a summation notation. I think those are fairly easy part. Now, this sequence looks like this. A, N. Okay, so this is a sequence. This is an infinite sequence A, N. That is a function that the domain is the set of a positive integer. Positive integer means 1, 2, 3, 4, 5, positive whole numbers. And then the function value or the terms of the sequence are represented by what? By A1, A2, A3, and so on, right? So this is a sequence. And the sequences, that domain consists only of the first n positive integer are called finite sequences. So if you stopped somewhere, like you stopped at 100, then that's a finite sequences. And if it's continued, then it's called infinite sequences. So this is just a very basic concept. And usually I will give you the formula for a n so you can find the terms. Let me give you the first example here. I give you a n equals 4n minus 1. Can you tell me what is the first 4 terms of this sequence? First 4 terms. What I'm looking for is a1, a2, a3, and a4, isn't it? But I already give you the formula. So for a1 here, in this case, n here is 1. That would be 4 times 1 minus 1. So that is a 4 times 1 minus 1, which is a 3. And the second term, a2, that is a 4 times 2, which is 8 minus 1. So 4 times 2 minus 1, and that's 7, right? And then a3, that would be 4 times 3 minus 1, which is 11. And then the fourth term is 4 times 4 minus 1, and that is 15. So if I ask you what is the first 4 terms, your answer should be 3, 7, 11, and 15. That's the first 4 terms of this sequence. So in this case, I give you the formula, and that an looks like a function of n, so you can go ahead and solve it. And sometimes I give you another form, it's called a recursion formula. What does that mean? That means this. I might give you a1 equals 3. Okay, I give you the first term, and then I tell you an is 3 times a n minus 1 minus 1 for n greater than or equal to 2. So what it says is this. I give you the first term. And then starting from the first term, and then you need to go to the second term. And then see, I have the formula for the second term when n is greater than or equal to 2. So that's the second, third, fourth terms. And each term is 3 times the previous term. n minus 1, this is the previous term of this one. 3 times it minus 1. So I go a1 is 3. Okay, so that's easy. Again, I ask you to find the first 4 terms. So a2 will be n is 2. So that's 3 times a, and here is n minus 1. When n is 2, here's 1, right? So again, that's a previous term. So 3 times a1 minus 1. But I know the previous term. The previous term is 3. So it's going to be 3 by 3 minus 1. So that's 8. Looks good? And then a3. Again, a3 is 3 times a2, the previous term, triple it, minus 1. See, when n equals 3, here's 3, and the 3 minus 1 is 2. So that's a2. So 3 times a2 minus 1. And we know a2, which is 8. So 3 times 8 minus 1. 3, 8, 24. So here's 23. Are you ready for the fourth term? The fourth term will triple the third term minus 1. So 3 times a3 minus 1. And so that's 3 times 23, which is 69. Minus 1 is 68. So the first 4 terms looks like 3, 8, 23, 68. 8. That's the first of 4 terms. Okay, if I give you this recursion formula, it's not easy to find like A100. If I give you the formula, it looks like this. What is A100, the 100th term? You just use 4 times 100, which is 400 minus 1, you get 399. But this one, if I give you the recursion formula, it's not that easy, okay? You really have to do this one by one. And sometimes they give you something looks like this. an equals an minus 1 plus an minus 2. Okay, and I give you a1 is 1 and a2 is 1. So I give you the first 2 terms. And then starting from here, when n is greater than or equal to 3, and then every term will be the summation of the previous 2 terms. It is very interesting. So that looks like this. 1, 1, right? The first 2 terms is 1. And then the third term is the sum of these 2. So that's a 2, because 1 plus 1 is 2. And then the next term is 1 plus 2, that's a 3. And the next term is 2 plus 3 is a 5. And the next term is 3 plus 5, 8. And the 5 plus 8, 13. And the going. And there's a special name for that, right? If you don't really know, okay, try Google it. So, all right, now this is how do you determine give the first several terms. And then next time I'm going to introduce a new operation. It's called factorial. So that is n factorial. You might have learned this before, but I don't know. So n factorial will be n times n minus 1, which is 1 less than that, and the times 2 less than that. Okay, keep multiplying until you get a 3 and a 2 and a 1. You stopped at 1. All right. By definition, a special definition says 0 factorial is 1. This is by definition, so you don't need to do calculation. When you say 0, that's just a 0 factorial. Then 1 factorial is 1, because you just n equals 1. So 1, 1, and you stop. You just start, then you stop. And the 2 factorial will be 2 times 1, which is 2. Okay? And the 3 factorial will be 3 times 2 times 1, which is 6. Okay? 4 factorial should be 4 times 2, 3 times 2 times 1, which is 24. And the 5 factorial is 5 times 4 times 3 times 2 times 1. That's 120. And guess what? Your calculator, your beautiful calculator, has a function, factorial. If you have your calculator with you, did you see here? You see this? This one? See? X factorial. So let's try. If I want to find what is the 5 factorial, you do 5, and you click it, equal. See? You get 120. So you can do this from on your calculator. You don't really need to remember too many things. Okay, so after this, I'm going to ask you to do a little bit more, which is a new term. Okay, so not a new term. I will ask you to do, for example, this. Can you give me the first of 4 terms of this? an equals 240 over n minus 1 factorial. Give me the first of 4 terms. So I need a1, I need a2, I need a3, I need a4, okay? So a1 equals 240 over, and this is 1 minus 1, which is a 0 factorial. By definition, that's 1. So it's a 240 over 1, so that is 240. And a2 is 240, and then down here will be 2 minus 1 factorial, and which is 1 factorial. Okay, and a 1 factorial is just 1. So it's 240 over 1. The answer is also 240. Now a3 will be different, because the denominator here will be 3 minus 1 factorial. That is 2 factorial. Okay, what is a 2 factorial? That's a 2 times 1. So that is 2. And the top is 240, so the answer is a 120. And a4, that's 240 over n is a 4, so it's a 4 minus 1 factorial. So that is a 3 factorial. And what is a 3 factorial? 3 by 2 by 1, which is a 6. Okay, so that answer is 40. All right, now what are the first 4 terms? 240, 240, 120, and 40. Okay, so that's the first 4 factorial. The first 4 terms, I'm so sorry. All right, now there's one more term we need to learn. It's called a summation notation. All right, this looks like it's read as a sigma. Okay, sigma of AI, and this I goes from 1 to n, and this is the term, AI term, and the I is called the AI has a name, AI called index. Okay, this is the index of summation. That's why we use little I, but it doesn't matter. So I go from 1 to n. That means I need to add a1 and a2 and all the way to an. So I need to add those n terms. So I goes from 1 to n. So you can count. There should be like an n terms. And that's a1, 2, 3, 4, a1, a2, and all the way to an. If I ask you, what is AI? I goes from 3 to 5. Okay, so this means I'm going to do a3. I will start from 3 and add 5. So that will be just a3, a4, and a5. Okay, so lower limit, upper limit, index, summation notation, sigma, the term. So it's not bad, right? Okay, so let me ask you to do one more. So I'll go x equals 1 to 4, and I go I plus 1 square. This is the term. The term, AI term, looks like this. And then we're going to have I go from 1 to 4. So it should be 1, 2, 3, 4. You can count. There should be like 4 terms. And the first term, I equals 1. So that is 1 plus 1 square. And the second term, I equals 2. So that's 2 plus 1 square. The third term, 3 plus 1 square. The fourth term, 4 plus 1 square. Okay, and that is 2 square, 3 square, 4 square, and 5 square. So that's a 4 plus 9 plus a 16 plus 25. And that answer is, because 9 plus 25 is also 25, plus 25 is 50, so the answer is 54. Okay? Now, see, here is the ith term. Now, let me ask you a very tricky one. So if I go I from 1 to 4, but I have a 3 here, what does that mean? That means I get a sequence, but this sequence is 3, 3, 3, 3, 3, 3, 3. It is a constant, just a 3. But I want to add them up. I want to go from a 1 to 4. The index go from a 1 to 4. So there should be like 4 terms. I need to add them up. And each term is the same. Okay? So that's 12. So don't be tricked if here there's no I. No I means just use that number. All right, so this is the sequence and the summation notation. I hope you had fun. I think this is very easy section.